All right, we're getting closer to the birth of cognitive psychology as we introduce the topic of cognitivism. So you can tell we're not quite there yet because we're not declaring a whole new field. But within the field of behaviorism, there were researchers who started to say that in order to understand behavior, we must start to understand cognition. These things that Hull and Spence had been mentioning previously on the last lecture that I was talking about, this idea that there might be an intervening variable, or there might be, some thoughts going on inside the learner's head. We have to start addressing that, argued the cognitivists. Some things that really made their case that we have to start to understand cognition were findings such as the discovery of mental maps. So what you're seeing on the screen here is a graph that shows along the x-axis the number of days that the rat has been attempting to learn the maze. Along the y-axis is the number of errors that the rat makes on each trial, on each day as they attempt to go through this maze. Now, if we look at the dotted line, the little dots that are labeled continuous reinforcement, that's the pattern of learning that you see in a rat who every single time it successfully makes it through the maze, it gets rewarded for that every single time. And so you see very quickly the rat is making its way through the maze with relatively few errors, so that by day 17, they are making, on average 8 errors. Now, if we look at the solid line that's labeled no reinforcement, we see a rat who never gets reinforced as they're going through the maze. They're just wandering around. They make slightly fewer errors as they get down to day 17, but not that much better, right, than they were doing on day 1, because they're not being reinforced. They're just wandering around. There's no purpose in getting out of the maze, so they're just sort of wandering around sniffing things. If you look at the dashed line, these are rats who are not reinforced for the first 11 days that they experience the maze, and they start getting reinforced on day 12. And look at how their random wandering around behavior, it looks just like the no reinforcement rats to start with. But on day 12, they not only show really rapid evidence that they know their way through that maze, but they're actually doing better than the rats who had experienced continuous reinforcement, almost as if it's more meaningful to the rats who hadn't been reinforced at the beginning to now suddenly be getting reinforced. The fact that they show such dramatic learning between day 11, where they weren't being reinforced, and day 12, when they suddenly were, shows that those rats had developed mental maps of the maze. And you can't look at this kind of performance and say anything other than there was something going on inside these rats' heads. Like, there's nothing else you can say. And so we have got to start talking about cognition. So another thing that was discovered almost exactly the same time as the mental map issue was latent learning. So in latent learning, well, let me put it this way. Latent learning was revealed when a study design did not go the way it was predicted. So what you're looking at here is you've got the starting place at the bottom, and you've got the food box, which contains the rewards, at the top. Path 1 is a straight shot from starting place to food box. So of course that's the preferred rat route, right, is to just take path 1. So path B, if you were to block path 1 at the point that's labeled block A, the rat would be able to take path 2 and very quickly get back on the path 1 and be able to get to the food box. If you block path 1 at position B, path 2 isn't going to help you. You got to take path 3 and go into the food box. And what they found very quickly is that the rats showed that kind of understanding. It's kind of an elaboration of the mental map issue, that they clearly understand how this maze is structured, so that when they encounter a block, they have the best route available to them to be able to go around it. And what the thing that they discovered is that the rats would not demonstrate that they knew anything about path 2 or path 3 until the conditions were favorable and they actually got reinforced for taking one of those other paths. Like, they would take path 1 if it was available. They would only go to path 2 if they encountered a block at block A's position. then they would display this latent learning, this learning that was inside them but had no reason to be expressed until it was necessary. And then they'd show, see, I know how to get around. I take path 2. It's the shorter way, right? Or if they run up to block B and they go, dang it, I'm blocked. They wouldn't go back, try path 2, and then try path 3. They would go back and go right to path 3, showing that they knew the strategy, but they only could reveal their knowledge when the circumstances were advantageous for displaying that knowledge. And they coined the term latent learning to explain what these rats were experiencing. So in the face of these mental maps that the rats clearly are carrying, and this latent learning, this idea that you'll only show what you know when it becomes advantageous to you, cognitivists really argued that we have got to understand cognition if we're going to be able to explain all of the kinds of behaviors that are being observed, even in rats, let alone in humans. Cognitivism really focuses in on the act of knowing and acquiring knowledge. Like, how do those rats know what the maze looks like if they haven't been making it all the way through each time, or they weren't being rewarded? How do they know path 2 is a better route than path 3 in some circumstances? Things like that. Like, how do they know that? So what we're really acknowledging in cognitivism is that there are internal thought processes. Now, I want to say something about B.F. Skinner being the founder of radical behaviorism that said, let's never talk about what's going on inside the learner's head. He wrote a lot of papers. He clearly knew that he had thoughts going on inside of his head. He was not trying to say that thoughts don't exist. He was just saying to introduce thoughts, to introduce cognitive processes into this model is to muddy it up, is to make us not as solid about what we really are confident about and what we're kind of guessing about. The cognitivists were arguing we are limited in what we can study and what we can talk about, and the degree to which we can really understand learning if we are refusing to talk about internal thought processes. So we've got to do that. Tolman started talking about this in the 1930s. So that's pretty quick after the founding of behaviorism, which happened in the 1920s. But he really didn't catch on at the level that you might expect when he's saying something so obvious, in part because behaviorism was very powerful. This idea that, we should understand at least these most basic things before we start stretching and trying to explain the unobservable things that are going on inside the head. So we finally are at the point where we're going to have the emergence of cognitive psychology. And signal detection was actually a part of a field of psychologists called Gestalt psychology. Signal detection was really looking at how loud does a sound need to be, how bright does a light need to be for us to actually detect that stimulus is there. So signal detection is sort of a binary kind of event where it's either you noticed it or you didn't. It was noticeable or it wasn't. One of the things that they discovered really quickly in signal detection is that it's not a clean binary code where for every person or dog or whoever the subject was, for every participant, that the level of the stimulus could be the same and they would notice it. Even within an individual, they saw variability in how loud the stimulus had to be for them to notice it this time, or how bright the light had to be for them to notice it this time. And the only explanation they could really come up with is motivation. Wanting to detect it can affect whether the participant actually responds to the stimulus or not. I call the subjects S's, so that's what that S is. So the motivation level can affect whether the S, the subject, responds to the stimulation. So if you really want to detect it, the stimulus can be presented at a lower level and you will detect it. Then if you're not really paying attention, you're distracted, something else is more interesting to you, it'll take a bigger stimulus for you to notice it. Fechner first noticed this in 1851. So some of the founding issues having to do with cognitive psychology specifically are very old. So you see this little chart on the right-hand side where you have sort of this binary thing, right? You either have a hit or you have a miss. But within this hit or miss, you have times where you hit because you say yes when in fact the signal was present. You have times where you correctly reject the stimulus and you say no when it really wasn't there. But then you have these other kinds of events where you say that you detected the signal, but it wasn't there. You've all taken hearing tests, I'm sure, and you're always wondering, did I actually hear it? You're like, I'm supposed to put my finger up, but I don't know, is that just my ears ringing? I don't know. You're worried about a false alarm. You're worried that you're going to say you heard it when it wasn't really there. And then misses would be times when you say no, but the signal really was there, which is the other thing we worry about with a hearing test, right? I'm going to say I didn't hear anything when in fact I should have heard something because there was a sound. So it's a little bit more complex than just hits or misses, right? It's hits, misses, false alarms, and correct rejections. I like to lump the correct rejections in with the hits, right? I feel like those are correct answers, and then we have two types of incorrect answers. So here's a nice graph of the way that signal detection really goes. It's not an on-off yes-no. You have this smooth curve where you go from, when there is no signal, the person basically saying, no, I'm not detecting anything, to some mixes of misses and false alarms and stuff like that. And then you start getting to a certain level of the stimulus and you're getting all hits, all correct yeses. And so Fechner, back in 1851, recognized that there are some factors that can go into the false alarms and the misses. Like if you really want to do well, you might be saying, oh yeah, I hear it. Oh yeah, I hear it, when really there's nothing there. So these kinds of motivational factors can muddy up our signal detection. So he was the first one to really sort of talk about things that are going on inside the individual can affect their outward behaviors. So you can tell from my label here that I think this was a huge event in the history of cognitive psychology, and that was the huge thorn in behaviorism's side, verbal behavior. Back in the reign of behaviorism, they didn't talk about language per se, they called it verbal behavior. In fact, there was a journal called the Journal of Verbal Learning and Verbal Behavior. So they weren't even really willing to talk about language as being something that goes on inside the head or anything like that. So how could verbal behavior be a thorn in behaviorism's side? Well, back in the 1950s, Skinner attempted to explain language acquisition through classical conditioning and operant conditioning. So he said that when the child used the correct word for something, let's say said cookie, they tended to get rewarded for it by their environment. They got to have the cookie, or they were encouraged, that's right, good job. And they were punished for incorrect use. They didn't get a cookie, or they were told, no, that's not how you say it, it's this, or something else that was kind of punishing. And so Skinner thought children learned language through exposure, right? And then being rewarded and punished as they were kind of trying to acquire the language so that ultimately they would come out speaking the language. Now, I don't think anybody's denying that exposure is a super important aspect of language learning. Everybody agrees with that. Children who are spoken to a lot, who are read to a lot, tend to have bigger vocabularies. They learn, we don't have a lot of evidence that they learn language earlier. That is not necessarily true, but they have larger vocabularies. They tend to pronounce things better, things like that. But along came Chomsky in 1959, and Chomsky said, I don't know about this whole reward and punishment as the primary way of learning language. He said, there's something that cannot be explained through rewarding and punishment, and that is something called an over-regularization error. Over-regularization errors happen in every language. And they happen to different kinds of words, almost exclusively verbs, but they can also happen to things that need to be pluralized or made into superlatives. So they can happen to lots of different kinds of words, and they can happen to languages all around the world. And they tend to happen, interestingly enough, around the same age all around the world. So to give you an example, hold on. Yeah. In English, if you want to say something happened in the past, typically you put an ed on the end of the verb stem, and now it's happened in the past. So you have things like played, right? Tapped, kicked, right? You just put an ed on the end of it, and now you've made it into a past tense. But there are some what we call exceptions to that rule. And in those verbs, you just have to memorize the correct past tense form. So, for example, said is an example of an irregular verb. The infinitive is to say, and normally you would put an ed on the end of it, and you would, I said that, but instead we pronounce it said. We don't spell it said, we spell it differently, right? So that's a good example of an irregular past tense word. How about something like to go? In the past, you went. So these kinds of irregular words occur in all languages. I speak pretty bad Spanish, but I at one point was pretty good at it. I minored in it in college, but one of the best examples of this kind of conjugation problem, this over-regularization, is the verb I know or to know. And if you want to say I know, you conjugate it differently than you would all other past tense verbs. So the verb is saber, and to conjugate it correctly, you would say. To follow the rule, you would say sabo. Sabo is baby talk. Wented or goed is baby talk, right? We all know this. This is baby talk. This is called an error that all kids do. And it's in all the languages. I just shared with you the 2 languages I can kind of speak, but every language has these kinds of things. So why is that? Why would you have really consistent errors that kids make? And you see it all across the world with different languages and different cultures. You don't see parents reinforcing their children for saying wented or goed. They usually fix it. They go, that's right, we went. Or, right, they usually just fix it for their child. So these irregular words really illustrated that Skinner's theory just doesn't explain language acquisition. When you can see something that is not being explained by the theory, there's something wrong with the theory. So Chomsky argued, we're born with a universal grammar in our head. We are not born knowing the grammar of any particular language. We are born with the ability to acquire the grammar of any language. And as babies, we are really, really just primed to be picking up the rules. And so what Chomsky argues is that once our vocabulary gets to about 1,000 words, we can't just use our memory anymore, and we have to start relying on that universal grammar system. And so the system picks up the regularities and figures out, okay, if I want to say it happened in the past, I put an ed on it, and now I can just apply that rule on the fly, and I don't have to memorize all these words. I don't have to have a store for the word played, and a store for the word went, and a store for the word tapped, right? Instead, I can just say, okay, all the normal ones, throw an ed on the end of it, and I'll put all these words over in the normal category, and then all the irregular ones, I'll store those separately. Much more efficient. So Chomsky argued it's not a reward and punishment situation. It's an innate grammar thing, and we have got to start talking about things that are going on inside of people's heads. We've got to start a field called cognition to talk about these things. And so that's really what prompted this conversion from this, everybody was sort of stuck saying, well, until we've answered all the questions that behaviorism can answer, we shouldn't move on to something else. And a bunch of people sort of rebelled in the early 60s and said, we're starting this new area called cognitive psychology, and ta-da, it emerged. This is a really great time to break, so we'll come back and we'll talk about the human information processing paradigm in the next segment.